All right, so physical and chemical properties and changes. I love showing that at the beginning, um, not just for entertainment value, but also because it's a very good demonstration of both chemical and physical changes and properties. Okay, so let's start with the properties, physical properties. Physical properties are any properties of matter which can be perceived or observed without changing the chemical identity of a sample. Okay, so the example I give you here, one property of H2O, or two hydrogens and one oxygen together, water, is that it can be boiled. Okay, and it can change from a liquid to a gas. Okay, now that's a change of state. And so that's a property. You can see that happening. You see the steam changing. Okay, it's not changing what it is at all, it's just changing its state. A chemical property is any of a material's properties that can become evident during a chemical reaction. Okay, that is any quality that can be established only by changing a chemical substance, by changing a substance's chemical identity. Okay, and so we have these logs. Okay, this wood, and when it is ignited and there's a combustion reaction, we're going to talk about that right away, takes place, it changes what the wood is, right? When you're done having a bonfire, it's no longer wood, it's a pile of ash, right? It's changed. So, some examples, okay? Combustibility, the process of burning something. Okay, so that is a chemical property, okay? Reactivity.
20,000 pounds of highly dangerous metallic sodium head for destruction in Lake.
Okay, and so this video I'm going to show you. In one of the first videos I showed you, it showed a big piece of sodium getting thrown in a lake. And so this has to do with reactivity. So when a substance changes chemically, so you can see here, sodium is Na, right? Metallic sodium. And when it's added to water, H2O, this is more a little bit more advanced, close to grade 10 stuff, but it's good for you to see, okay? It yields or gives you sodium hydroxide and hydrogen. Okay, and so anyway, this is just a video of the disposal of 2,000 pounds of the stuff into a lake. It's from 1947.
Lenore, Washington. The government surplus chemical ignites and explodes when wet. The alkali lake is devoid of fish and forms an admirable disposal spot. A 3,500-pound container of sodium hurtles into the lake and crashes through a foot of ice. As the water seeps in, smoke rises through a series of muffled explosions. The acrid clouds billow several thousand feet over the steep sides of the lake. Disposal of the chemical by the War Assets Administration is made necessary because no public carrier will accept it for transportation to a purchaser. One after another, with varying effects, the containers go up with spectacular results as water and sodium meet. A once lethal war chemical becomes a peacetime pyrotechnic display.
Okay, so again, that's demonstrating reactivity, which is a property, a chemical property when substances change what they are, right? So again, it's showing we're changing its state. It's completely changing what it is. Okay, toxicity. This refers to how poisonous something is. Okay, it's accumulation in the body. All kinds of things can be toxic, but in any case, this is what toxicity means. Okay, how poisonous something is. Stability refers to a resistance to chemical, to changing. Sorry, refers to changing the way it is. Okay, so we have a very unstable chemical here. Okay, you'll remember from your Bohr model work. This is hydrogen. Okay, we have one valence electron. That means that it's very reactive, very unstable. Um, on the other hand, helium here, right, with two valence electrons, having a full valence shell is very stable. Okay, and so that's what we mean by stability. Helium will does not combine with other things in nature. However, um, hydrogen does. Okay, now moving on to physical changes. Okay, so um, this does not change what the substance is. Okay, when we're talking about physical changes, when we're talking about making the distinction. Okay, a substance may change from one state into another. Okay, you've got a picture of an ice cube here, right, which is water, frozen and liquid. Okay, right. A lot of physical changes are reversible. Okay, for example, freezing and melting ice. You can freeze ice, you can melt ice. Sorry, you can freeze water, you can melt ice, you can boil water and make it into a gas. Okay, um, so dissolving substances in water is a physical change. So when your mom tells you to gargle with salt water, or you make a powdered drink of some kind, that is a physical change, not a chemical change taking place. Okay, right. If the water evaporates, you get the substance back. Um, so if you're making a drink and you put, I don't know if you've ever noticed when you have like a sugary drink, like a Kool-Aid or something, and if it gets left out for a really long time and all the water evaporates, what are you left with at the bottom? Usually there's grains of sugar and crystal and drink crystals at the bottom. Okay, so one example, of course, here, and I give you a little bit of a video, a time-lapse video, is ice melting. This is just somewhat satisfying to watch. However, I will not make you watch the entire thing. Okay, another example of a physical change is just cutting paper, right? Or you change the shape of something. You're not changing what it is, you're just changing its shape, right? So if you take a piece of paper and you cut it, um, it is it's just changing the shape of it. Making Kool-Aid.
Oh, yeah. Uh-oh. Huh? Oh, yeah. Oh, yeah. Kool-Aid's here, bringing you fun. Kool-Aid's got thirst on the run. Get a big...
All right, so making Kool-Aid. I mentioned this one already. But you add those drink crystals and the sugar to water. You're not doing anything to change the water. You're actually making a mixture, which we'll talk about as well. Uh, you're making a homogeneous mixture, but it is a physical change, not a chemical change. Nothing has changed about it. It's still a mixture. Okay. When a substance is changed, so this is now we're going to talk about chemical changes. Um, okay, love eggs. Got farm fresh eggs. Have chickens, and um, you'll see I give a lot of examples of with eggs for chemical changes. But it's when a substance changes into one or more different substances. Okay, and so in this particular case, we can see the chemical change happen right before our eyes. Right, it changes from one substance to another. A chemical change is usually not reversible. Um, don't ask me how. Apparently, they've learned how to unfry an egg, but it is usually not reversible, or it's very difficult to do. Okay, this is different from physical changes where they are definitely reversible, right? Melting ice, freezing water, boiling water. They're fairly easy to do. To unfry an egg is very difficult, near impossible. Okay, yes, I put down, can you unfry an egg? Okay. Um, Now, I want you to take note of this, okay? Because whenever you're looking at whether something is a chemical change, okay, whether there's a chemical change taking place, you need at least two of these things to happen, okay? So heat is absorbed or produced. So that means that it makes it cold or it makes it hotter, okay? To put it simply, there's a color change. Okay, so you could see with the egg there's a color change. It goes from like a translucent jelly, clear see-through jelly um, to a white color, right? A precipitate is formed. Okay, so this means that a solid in a solution. So precipitate refers to like precipitation. You've heard of that before, rain falling to the ground, right? So it means falling down, and so we have some substance being created in the solution that's falling down, usually to the bottom. Okay, a substance is used up. Okay, so the starting material or a new substance appears, or a gas is produced. Okay. And again, like I said before, you usually need at least two of these signs to know it's a chemical change. Okay. So another example of a chemical change, metal rusts. This is a time lapse of metal rusting. And so I'm gonna let it play here for a minute because it is pretty neat. But as you can see, more and more of those spots are showing, right? That is the metal reacting with the oxygen in its environment and changing what it is. All right. Here's another example of a chemical change. Okay, one that I give you. Vinegar reacts with baking soda, right? How many of you have ever done this before? They made a rocket out of this one. Okay, pretty cool. Something you could do at home. Be very careful if you do. Another example of a chemical change, baking bread. You know, mom, grandma, dad, whoever makes your bread at home, if they do make bread, um, bread starts off as a number of ingredients that get mixed together. Flour, water, yeast, um, sugar often, and uh, and then turns into this light, fluffy stuff that we eat, right? And so there's definitely a change. It goes from this ball of dough into this light, fluffy thing. It's changed what it is chemically. Okay, and gases are released. Okay, and here's another that's nice, quick. You can see here the time lapse of an egg. Another example of a chemical change, frying an egg. Okay, gasoline burning, another example of a chemical change. Okay, internal combustion engine. There is a chemical change taking place in there. We have gas or diesel being fed into a piston, right, and it being ignited and releasing gases and different products. Okay, carbon dioxide and so on.